Good evening and welcome to our Jupiter Isolating live stream. We come to you from lockdown Melbourne again. But before we commence, I'd like to say that in the spirit of reconciliation, the Astronomical Society of Victoria acknowledges the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respects to their elders, past and present, and extend that respect to all Aboriginal Torres Strait Islanders people today. Tonight, we hope to bring you the eclipse of Ganymede and Callisto as it comes out of eclipse. It's known as a eclipse phenomena, and to describe it in greater detail, we have Stuart Beveridge from our Lunar and Planetary Section Director and an ASV member who's heavily involved in Lunar and Planetary, Barry Adcock, as well as another ASV member heavily involved in Lunar and Planetary, Andrew Amiet, who's come along as well, and our team of live streamers. So let me bring them in. So we've got Stuart Beveridge.
Hi, everyone.
Barry Adcock.
Yeah, good evening, everyone.
Andrew's here as well. And our usual cohort of live streamers. So what we thought we might do first up before we get stuck into the live streaming and hoping that some of the guys can be able to bring us the views of Jupiter and its moons through cloud at the moment. We thought we'd get Barry to share some of his knowledge on Jupiter and explain exactly what's going to happen tonight. And if you've got any questions about the stream or about what we're going through, what we're talking about, and what we're going to show you, pop them in the chat section and we'll answer them as best we can. Barry, it's over to you if you want to get started on your little talk.
Thank you, Mark. Can we bring up that PowerPoint?
Yes, it's already up. You'll have to go back to the start of it, though. When you're ready.
Yeah, what I'd like to briefly explain is exactly what's going to happen this evening. And what I've got there is a picture of Jupiter. North is at the top.
We can't see it just yet, Barry. You'll have to start your slideshow again.
Shows it.
If you could share that again, and we'll get it started again. In the meantime, while we're waiting, we might just...
My screen's gone blank.
Ah.
Yeah, I'll do this alt.
While we're waiting, Stuart, do you want to have a chat about what we're looking at right now?
Well, thanks, Mark. What we're looking at right now is Jupiter, and what's going to occur tonight is two of its largest moons are going to, one of them, Callisto, is going to come out of eclipse, and Ganymede is going to go into eclipse approximately 9 minutes later. So at the moment, I would say that through fairly ordinary conditions, we're probably looking at Jupiter and Ganymede.
I believe that's what we are looking for while we wait for Barry to get things sorted from his end.
Well, I think it's sorted. I've got it up on my screen. But
if you could share your screen again, we'll get it up for everybody else to have a look at. So this is a live view through Noel's telescope up in Bendigo at the moment. He's not got. This is through clouds, isn't it, Noel?
Yeah. We're fighting clouds at the moment.
We are indeed fighting clouds at the moment. So what equipment are you using to bring us this view?
Yep. It's a 180mm Maxitov Cassegrain telescope, and that's got a native focal length of 2.7 meters, and I've also got a 2 times PowerMate on there to take it up to 5400mm focal length, which is why I can get such a big picture of Jupiter on there. But it is overkill. I could do without the PowerMate and just zoom in on it, and then the picture would be just as good. It's shocking seeing tonight. So hopefully it thins out a bit and improves for us when the event happens.
Now, Barry, have you got your screen ready to share again?
Well, it's up on my screen. Yep.
You'll have to go to the share button again at the bottom and share your screen, and we'll get it going for everybody else as well.
There is no share button.
On the bottom of the StreamYard screen, there is a share button. The share button you click. While we're doing that, Andrew, did you want to pop in and explain in detail what this, because this was something that you brought to my attention this stream. Would you like to jump on and have a chat about what exactly is happening?
Sure, no worries. Hopefully you can hear me.
Yep, we can hear you.
Basically, the moons are traveling behind Jupiter, behind the shadow of Jupiter, as it goes, as they transfer behind the planet, but after behind the sun. So at the moment, Callisto is behind Jupiter and you can't see it because it's basically in shadow, and Ganymede is going to move into Jupiter's shadow at just about the same time, a couple of minutes before Callisto comes out of Jupiter's shadow. So there'll be a transfer of the visible moons as the night progresses, if we ever get some clear skies.
We might jump to Lee's. We might jump to Space Engine. And Barry, maybe instead of looking at your PowerPoint presentation, we could do a similar thing here with Space Engine, as Lee's got it set up pretty well. So if you'd like to work through your talk from the Space Engine point of view, you could explain what you were going to talk about. And then maybe following that, we could also answer some questions that anyone in the public has, and just some general features of Jupiter as well.
I can't see why I can't.
I think you've got to share your screen again, but that's okay. That doesn't matter.
Yeah, but I can't get back to the. Oh yeah, there it is. There
we
screen,
go.
Share.
So for those watching, this is a view of Jupiter, and
has that come up?
No, not yet. It hasn't, Barry. I will let you know when it does, though. Keep trying. This is a view of Jupiter, as we will see tonight, with Ganymede and Callisto sort of just off to the right-hand side. They're about to go into eclipse. We don't have these seeing conditions tonight, unfortunately. Ooh. So Lee's now zooming in to Ganymede and Callisto. And Stuart, would you like to tell us a little bit about those two moons?
Yeah, sure. So in ranking of the largest moons, Ganymede is the largest moon in the solar system. Its average diameter is 5,262 kilometers. The second ranked moon is Saturn's moon Titan, but Callisto is the third largest at 4,821 kilometers average diameter. So currently Callisto is in eclipse and will come out of eclipse, followed 9 minutes later by Ganymede going into eclipse. But they are very big moons.
Mark, I have this share in front of me with a plus sign on it.
Yep.
Should I only share with? I thought you were going. I thought you could bring it up.
I can't share your screen. You've removed it from the stream, so you'll have to share it back in, and then I can let everybody see it. The other option, Barry, if you are having issues, if you want to email it to me, I'll be able to bring it up for everybody as well.
Well, there it is on my screen. Can you see it?
No, we can't see it at all.
Well, I'm not sure what to do.
If you'd like to just quickly email it to me, I can pop it up for you.
Righty-go.
That might be
Well,
the best way.
You can email it to me if you prefer, Barry. That's okay.
No, either way,
We'll get it up, and then the viewers can see what we're talking about. Lee, can you put an aerial view on that, showing one of the similar to the slide that we were going to be looking at? There we go. So this is a very similar view to what Barry's going to be talking to us about shortly once we get his presentation up. We've still got about half hour or so until the eclipses occur. So this is just almost like Jupiter is the center of its own little solar system there, with everything going around it. And it's what moons have we got there, Lee? Who's on mute and doesn't know he's on mute?
He also does not know he's on mute.
Yeah.
Rightio, I've just sent it, Mark.
Thank you, Barry. We'll get this sorted. We will get there. We're battling clouds and technology tonight. It's what amateur astronomy is all about, isn't it?
Yeah.
All right.
Yeah, there they are. Sorry, I had to go out further. So, yeah, so there's Ganymede there, and this should be Callisto here. Anyway, I'll just go back in briefly. You can see the sun on this side and the shadow on that side. And if you were to draw a line along here, you'll pretty much see, as Stuart and Barry's already mentioned, that Callisto is probably already eclipsed. And just due to the rotation, Ganymede will come out first, I think that's the way it is, isn't it? So if I actually speed up the animation.
Yep, Ganymede is currently visible, but Callisto isn't, and they will swap over.
Yeah, so now, again, you'll see here that Ganymede comes out quicker, and Callisto's, I think the determination was, you think it's around 9 minutes different, was it?
Yep, 9 minutes.
Oh, look at that.
There should be 9 minutes where you can't see either of them.
We have a slideshow. How's that?
Good.
Very nice. Excellent.
Now, that's only the heading. Can I move through that?
I'll jump through that for you. There you go. How's that?
Yeah, well, the first slide, everyone, shows approximately what Jupiter would look like tonight. That's a genuine photograph of Jupiter with North at the top, and on the left is Europa, the extreme right is Io,
Whoops.
and
We'll go back. Sorry about that.
Ganymede and Callisto are shown there, and you would get the impression from the first sight that Io was in an orbit outside Ganymede and Callisto, but that's not so. And if you just move to the next slide, Mark.
There we go.
Yeah. This is not absolutely drawn to scale, and the first problem is that I've left an L out of Callisto, so I'm very sorry about that. But it does show the orbits of Io, Europa, Ganymede, and Callisto, roughly to scale. The blue line shows the view that we are looking at Jupiter and its satellites, and the red line shows the illumination of the sun, and that's why the shadow represented in black is off to the upper right, and that angle is probably just a little bit bigger than it should be. So you can see now that Io is further to the right of Ganymede and Callisto, and that's why it looks like it's further away. Europa is coming around from the left, and sometime in the very near future, it will there'll be an occultation of Europa. But the two at the top show exactly what's happened. Ganymede, I can't animate this, but Ganymede has already moved into the shadow, and Callisto is just about. Sorry, Callisto is in the shadow and it's about to come out. Ganymede is about to go into the shadow, and according to the ephemeris, Ganymede will enter the shadow of Jupiter at 22 hours 41 minutes, and 9 minutes later, Callisto will emerge from the shadow at 22 hours and 50 minutes. And that's what we expect to see. There will be a 9-minute period when we don't see any satellite at all, and then Callisto will, Ganymede will appear after that. So, sorry, I've got around the road. Ganymede is going to disappear. Callisto will reappear 9 minutes later.
Wonderful. Now, Noel, there's a question for you. What camera are you using?
Yes, it's a ASI 224MC, which is it's got a small chip on there. It's not cooled. It's a color camera. It's a small sensor, and it's ideal for planetary and lunar work. Unlike the sort of camera that you'd use for deep space photography, which would generally have a bigger sensor with bigger pixel size and cooled. So
it's a ZWO high-speed video camera.
Now, Stuart, why is high-speed important?
Yep.
So for the planet's high speed is generally important because we're trying to image the solar system through the atmosphere, and the best way of doing that is to try and freeze the best moments of the planets through the atmosphere, and it's the name for that is known as lucky imaging. And the ZWO224 that Noel has is a very good camera because it's color, so it can image the solar system as it occurs, and also it can go very, very fast. It's been around for a little while now, but it's still quite a very good fast video camera. But what we're trying to do is we're trying to get our exposure as short as possible, and we're trying to record moments where the atmosphere becomes steady, otherwise known as lucky imaging.
So when you do your imaging, you're taking video footage, and then how long do you take the footage for? Like, what's a normal sequence to then rip the images to stack?
Well, there's a number of there's a couple of techniques. One is using color cameras, and then there is another method where you can use a mono camera with 3 filters if you're doing it in color, which is red, green, and blue. But generally, you would image one video of Jupiter, depending on what size your telescope is and what focal length you're running, for around 60 to 90 seconds, maybe up to 120 seconds. Because Jupiter is a planet that rotates very, very quickly. In fact, it does one rotation in about, I haven't got it in front of me, about 9-10 hours. So you can't video it for too long. Otherwise, when you try and do what they call stacking of the good frames versus the bad frames, you can get blurring of the features if you video it for too long. But what we're trying to do is we're trying to run high-speed video, as shorter exposure as possible, and we're trying to stack frames to get a good image of the planet.
So this is a live view that we've got, obviously, of what's happening tonight. You can see 2 of its moons. Do we know which moons they are, Noel?
No, I couldn't tell you that bit. That's more.
Well, they're Callisto and Ganymede.
Is that both of them? So Callisto hasn't gone into eclipse yet.
Maybe not. Sorry. Yeah.
No. That'd be Io.
Io.
No, I think Ganymede and Io.
Ganymede and Io. There we go. I was going to say.
But,
Yeah,
that'll be
Io is,
Ganymede and Io.
and a little bit off to the left, there's Europa.
Unfortunately, the conditions are a bit average tonight, but
They are. But we're
considering the
doing what we
conditions,
can.
the conditions, it's looking. Noel's doing a great job.
He is. He
I've got
most certainly
a
is.
shot. I've got a shot at the moment, but
yeah. I,
it came out of the
Can I
clouds quickly. But yeah.
can I say a word about these times, Mark?
Yes, go for it. That's why you're here, Barry. You're one of our resident experts.
I've just opened up the Astronomical Almanac, which is published by the US Naval Observatory, and it tells me that the number 3 eclipse disappearance is at 12 hours 41 minutes. That's UT. It'd be 22:41 here, and the Callisto reappears at 22:49, which is a minute difference where the yearbook sits. So that's not much. So that really confirms the times that I read out of the ASB yearbook of 22:41 and 22:50.
So we were close.
Yep, we were.
We were. Now this is Andrew. This is a live view through your equipment. Now, what are you using when you do your imaging?
Okay, this is a 9.25 inch Smith Cassegrain. It's going in and out of the clouds at the moment.
Yeah,
so
we're losing it in the clouds a bit there.
Yeah, but we got a really good. I got a really good shot before, but it comes back again now. As it gets. Oh, here we go. I've been now blown out. So you can see them. You can see Ganymede there, but you can see some of the bands on Jupiter. I have the same camera, an ASI 224. It's just gone again, but it's going in and out of these cloud patches. It's coming back again now. Here we go.
The thrills and spills of astronomy, huh?
Move it down again.
Yep, that's definitely Ganymede on the right.
Yep, it's gone again. Trying to get it back. There we go. Oh, it's blown out again.
No, wouldn't it that far out though? Wouldn't it be IO or
No, IO's further around.
Further around again? Okay.
Yep.
Yeah, no, I think that is Ganymede on the right.
Oh yeah, it's definitely Ganymede. That's a 2.5x power mate. So I'm going to try and set up my camera to record this. Actually,
okay, so you're going to record this while we're streaming. So somebody's asked what that camera was. I think you might have just said, but I think they've missed what it was.
It's a ZWO ASI 224MC. It's a high-speed video camera. Specifically designed for planetary imaging.
Okay, so Andrew, you want to run us through exactly what you're doing here?
Okay, at the moment I've set the recording going. So it's recording now. It's recording the Bayard with the Bayard matrix on. So because it's a color camera, it's actually a black and white or grayscale sensor, but in the front of it is a Bayard matrix, which is red, 2 greens and blue dye in front of each pixel, which gives it the color. And this is how digital color cameras work. I've got to move that down a bit because we're starting to get a bit of a good patch. So I'm overexposing. There we go. So it's actually recording in what looks like a grayscale, but and pretty blocky at that. But it is actually recording in full color.
And then what do you do once you've recorded it? How long would you record Jupiter yourself when you do your imaging?
Well, I actually record for a bit longer. I probably record at the moment for now around about 10 minutes. And then I use another program to remove the rotational effects of the planet. So most people as Stuart said, will record for a couple of minutes, maybe up to 3 minutes. But using this specialized software called WinJupos, you can remove the rotational effects of the planet. And
So
then,
when you
brings it all
when
back
you say
together, and then you stack it all up.
when you say rotational effects, obviously Jupiter's rotating as you're imaging. So
Yep.
how does that remove those effects?
I'm actually not
Was
too
that,
sure.
Was that too
I think
technical, was it?
well, I'm actually not too sure. I think it grabs the pixels frame by frame. So I'll take 90 to 100,000 frames in a 10-minute period. And what it does, it shifts the pixels across each of them and over those 100,000 frames, and then puts them back to where they should have been had the planet not been rotating. I think that's right. Is it, Stuart?
Yeah, that's right, Andrew. It sets up a matrix of multipliers that the pixels in the middle have to move further than the pixels at the edge. So it's a fairly complicated operation.
Actually getting a big hole in the sky at the moment, so it's actually coming out quite good. If you can go outside in Melbourne at the moment, at least around where I am in Bentley, you can actually see the planet quite brightly now.
And ladies and gentlemen, all this software for planetary is free.
Yep.
So when what do you mean free? So all of the stuff you're using, all of the programming you're using to do this is free of charge. Obviously, the equipment's not. We know that.
What's happened?
Yes, Mark. All of the programs I use, and I presume Andrew is the same, are actually free. No charge.
It's brilliant. That's beautiful. So, Stuart, your gear that you've got, dare I ask how much that costs for your setup? Now, you've got a bit of a unique one. You've got a 16-inch Dobsonian, don't you, that you use?
Now, I've got a 12-inch F5 that I bought second-hand because I knew the guy who had it in his wardrobe, and his wife wanted to get rid of it. So I got it for a good price. And then I made what's called an equatorial platform, and that they can be made in the ASB's instrument making section. They make these platforms, and my telescope sits on top of the platform, and it will track the sky for 50 to 60 minutes, and then it will require resetting. And then I've got a couple of cameras similar to this.
You built that yourself, didn't you? That base, you did that in instrument making, wasn't it?
Well, I built mine at home, but they do build similar ones at instrument making. That's correct.
Now this is obviously, Noel, you've got some clear skies out there at the moment.
Yeah, there's a nice big window that's opened up, hopefully just in time, and it stays that way. Yeah. So
hopefully it hangs around for another 15 or 20 minutes.
Yeah.
Yep.
You can see Ganymede there off. Well. You can see Ganymede off to the side there. I might jump across to yours for a second there, Andrew. It's interesting to see just the difference in imaging, and that comes down simply to equipment and location and seeing conditions. So it's not just one thing that's causing these differences. It's a multitude of different things. So Noel's up in Bendigo, Andrew's down in Bentley. They're both using different cameras. They're both using different telescopes, and they've both got different seeing conditions at the moment.
So what we're looking at is we're looking at Jupiter in, it looks like it's in black and white, but it's recording in what's known as raw OBI. And when it gets processed, the color will get put back in.
So yes, unfortunately, mine's not going to look at that flash at the moment because it is in the black and white.
I don't know. It looks pretty crisp. We'll jump back across to the colour one. Now, while we're waiting, well, that's a nice look there, Noel. That's looking really good now.
Well, thank you very much.
While we're waiting, Stuart and Barry, did either of you want to have a chat about Jupiter itself? A little bit of information about the bands of Jupiter and why we see the different colours.
Yeah. Do you want to go, Stuart, or will I?
You go ahead, Barry, because Barry is takes a lot of spectral images of Jupiter in the infrared. So go ahead, Barry.
Yeah. Well, that picture that we have in front of us, first of all, a few things you notice as soon as you look at Jupiter, and one of them is that it's not round. Now, on our planet Earth, we rotate roughly in 24 hours. The Earth is a pretty solid planet, but due to the rotation, our Earth bulges at the equator by about 30 kilometres. The diameter through the equator is 30 kilometres greater than through the north-south pole. Now, Jupiter is much bigger, 11 times bigger. It's a gaseous planet, and it rotates in 10 hours. So Jupiter is visibly bulges by an enormous amount. 140,000 kilometres roughly through the equator, and it probably bulges about 20,000 kilometres. So that's the first thing to notice of Jupiter when you're looking at it through a telescope. It's not round. The second thing is the two equatorial belts. They usually look like they're grey at first, but if you look at them carefully, they're a fairly dark brown colour against a very light cream or yellow background of Jupiter. Other features are the north and south polar regions, which do in fact look grey, and they're much fainter than the equatorial belts. And then there's the temperate belts that come and go, and you can see those as well with a bit of difficulty. The colouring is it's interesting to read through the literature, and you see comments like, we still don't understand the chemistry of Jupiter's atmosphere. But basically the white zones are, Jupiter is basically made of hydrogen and helium, but near the surface there are other elements and compounds as well, such as methane and ammonia, and the lighter areas have a predominance of ammonia ice crystals. So the lighter zones are basically ammonia ice crystals. The darker bands have trace elements of sulfur and phosphorus and compounds of those that nature, and that's what is thought to give the bands of colour. It's also one of the greatest features on Jupiter is the Great Red Spot, of course, and it's thought that material coming up, the deeper the material is, the redder it is. So whatever is making up the Great Red Spot, it's actually coming up from the from much lower layers of Jupiter than the standard belts. There's also a feature on Jupiter, a little spot called Spot BA in the southern hemisphere, and often that appears quite red as well. In fact, it became known as the minor red spot for a little while. You've probably all heard that the Great Red Spot is shrinking, and at the moment measurements show that it's smaller than it's been in our recorded history. It's still not expected to actually disappear, but as it shrinks in size, it becomes more and more round. It's an anti-cyclone disturbance, which means that in the southern hemisphere it's rotating in an anti-clockwise direction. The
Ganymede is just starting to enter eclipse. So according to my Sky Safari app, it's just starting to go into eclipse now. Sorry.
So whatever image we're looking at, can that person increase the exposure? Excellent.
So you might start to see half the moon if we're lucky.
Yeah.
So yeah,
but
so that's what'll happen.
Take 8 to 9 minutes.
Yeah, so that lovely bright dot on the right-hand side there will slowly but surely get dull and disappear. And then about 9 minutes later, slowly but surely, to the left of it, it's Callisto, isn't it? Will start to appear, will start to get brighter.
It is a fact that the moons shouldn't just suddenly snap off if someone's turned off a light, because they've got a finite diameter. The shadow does take a short time to actually progress across the moon, so you should actually see it fade, although the beginning of the fading would be very difficult to discern.
Yeah, I think it's only after you've stacked a few thousand images that you'll be able to see a
shape,
half the moon. And I've captured that before.
Yeah, I didn't mean you could see half the moon. All I meant was that you can see it fade.
Oh no, you can see it. You should be able to see it after stacking. You'll be able to see half the moon.
Yeah,
as it goes.
Yeah,
but yeah, you need a few.
Just looking visually.
Images. Yes, it will be difficult.
So
and this is incredible, of course, I think, because you can, people who are watching this program, you can see this if you have the right equipment from your backyard, and I think that's amazing.
Now, what equipment would they need to be able to see something like this happen? Would a pair of binoculars suffice? A good pair of binoculars? Or would they need a small telescope?
I think to see something like this in much detail, you're going to need an 8-inch telescope or bigger, but maybe a 6-inch, you'd be able to see it. Would you agree, Barry?
Yeah, I think through a pair of binoculars, you can see the moons, and you would actually see one of them disappear and the other one reappear. So, yeah, you'd see them in perhaps 10 by 50 binoculars, but of course you wouldn't see any sign of any detail. Jupiter would mainly look like a bright dot, and the moons would look like stars. And I think you'd certainly see one disappear and the other one appear.
In fact, it's amazing what you can see through a standard set of binoculars. And the reason why people don't see this sort of detail is purely because they're holding them in their hands. And if you can steady your binoculars, you can actually quite easily see Jupiter and its moons.
So what?
But as Barry said, it looks like one very bright star and the rest very dimmer stars. But you can certainly see them.
So would you recommend a tripod then to go with binoculars, a nice pair of binoculars, or obviously a 6 or an 8-inch Dobsonian type telescope? Or maybe even if someone's got a little bit more money to spend, something that's a little bit that tracks so that it'll hold on the object.
Yeah, look, for Jupiter, Jupiter's quite bright.
Let's
jump across to Andrews for a second here. He's jumped right in on
refocusing.
Yeah, just refocusing. You got a nice view going on there. That's actually a quite a stunning live image of Jupiter. Sorry, Noel.
No, you're right. I'm going back to recording again now. So
it's okay. It'll go back to black and white.
Oh, no, it was still on finishing. So I'm waiting for this recording to finish.
It's that live view of Jupiter right there is better than some photos of Jupiter that I've seen. It's very crisp, that's for sure. All right, we'll jump back across to Knowles. Now, I think we can see another moon on the other side there, over on the left, right up in the top corner.
Yep, that's correct. Yep, that's correct. That's Europa.
So
I don't know about you guys, but it looks to me like
Callisto's coming out now. Sorry, Callisto's coming out of eclipse
Callisto's
now.
starting to come out. So I can see that.
See it coming in.
Yep, Ganymede's getting a bit duller.
Yep.
So Callisto is starting to come out. So that should start to appear between where Ganymede is on the right-hand side there and Jupiter.
That's at my location up in
Bendigo.
Where's Benalla, was it?
Bendigo.
The difference may be a slight difference in position may have it at a slight change, but
you can definitely see it's dimming.
Yeah, it's now a lot dimmer than what Europa is over there on the left-hand side.
Oh, yeah.
So it's certainly getting dimmer. And while we've been talking, it's actually gotten dimmer and dimmer again as well.
Yeah, it's in full eclipse now.
For you, it is?
Start coming up now.
Yeah, so from where Noel is, Ganymede is just still visible. It's really dull now. So I'm hoping all of our viewers can see this happening, how dull Ganymede has just gotten, and it's going to disappear very, very shortly. You won't see it sitting there in a moment. And then what you'll find is that once it's gone, shortly after that, from where we're looking at with this view, from where you're looking at with this view, Callisto will start to appear.
Callisto, yeah, that's right.
So I can just still see it. It's very, very dull now. So I think it's pretty much gone now. There's a tiny little, yeah, you can just still see it there. Or is that Callisto coming out now?
They'll be very close. They're not.
They are very close, aren't they?
By about, what are they separated by? A few arc minutes, a couple of arc minutes.
Well,
you can definitely see they're both in eclipse, but Callisto will reappear very shortly.
Very shortly, yes. Now, while we're waiting for that to happen, Mark wants to know if Noel and Andrew's cameras are identical. I'm not sure if they were.
I think so.
You are?
We're both ASO 224 MCs. Yep.
Yep. So same camera, different scope, different scene conditions, different location. That's our differences. Now, someone's saying they can see Callisto appearing, but I can't see it appearing just yet on this live feed we've got from Noel.
I think it's due to reappear in about 3 minutes.
Okay, so you'll have to listen to probably me just ramble on for 3 minutes, otherwise it'll be the sound of silence.
Like Ganymede, though, it will slowly appear. It won't just suddenly be there. It'll fade on.
Oh, now we've got a nice view of Jupiter while we wait. Hello, Ken. Ken from New Astronomer Group is watching. He just finished teaching our new astronomers for the ASV. So if you're not an ASV member and you want to become an ASV member, we do have a new astronomers section for those who don't know a great deal about astronomy. I'm one of those. I've been a member for over 6 years now and I still don't know a great deal. Ken hosts new astronomers meetings for new members once a month, teaching everybody about astronomy.
And Mark, once Callisto comes out, in about 15 minutes, maybe a little bit longer, the great red spot on Jupiter will start to rotate around from the left-hand side.
Oh, well, we can sit and watch that if the guys streaming don't need to go to bed.
Maybe it might take longer than that.
At the moment, there's a rainbow around the moon. So if you go outside,
there's a halo, is there?
There's a double rainbow around the moon.
At
my location,
cloud. Yeah, that's the thin cloud that's doing that.
The cloud is giving you a double rainbow.
It was happening the other night as well. We had a lovely big moon halo. Oh, you got some cloud coming in there, Noel, or?
Oh, no, just bump the exposure dial, that's all.
Yeah, that'll do it.
Are we able to brighten it back up to see Callisto coming back in?
Yeah, we'll turn it back up to where it was.
Yep. So
Yeah, in Ringwood, I can see the moon with the rainbow.
big halo. So John Darderman, who's another ASV member, is saying that using Stellarium, and Stellarium is a free program that you can use on the web or you can download. You can see it shows exactly the same time the moon's disappearing and reappearing, and that it's identical to what's happening right now outside.
Yep.
Now we should be hitting that point where we should start to see Callisto appearing from Noel's location. Oh, there it is. Yep, you just see it there. To the right hand side there. Very faint blob starting to appear.
It'll be a little bit closer to Jupiter than what Ganymede was, but not by much.
About a third the width of Jupiter itself in that image.
Yep. So there we go. We've managed we've managed to pull it together. The weather has played its part, and we've been able to bring you one moon going into eclipse and one coming out of it.
Yep, you can start to see it now.
Yeah, starting to get very clear now. Now we had another question from Mikhail. Wants to know if the Dobsonian platform handles azimuth, but I assume you need to manually handle altitude. Now that one is for you, Stuart.
Yeah, look, you can do that. There is with planetary, you can actually use an altitude azimuth scope and use what's called the drift method, where the planets will drift across, and you can run the video as the planet drifts across your field, and then pause it at the end, and then pull the telescope back and let it drift across again, and let it drift across again. But what I do is I've made what's known as an equatorial platform, which essentially turns it into an equatorial telescope for around 50 to 60 minutes, which makes life a lot easier. But you can use you can do this manually if you're good enough, but you've got to have a really smooth Dobsonian mount to do that.
So now, as Callisto comes out of eclipse, Barry, there's a question for you from Mark. He wants to know if the great red spot is fading in colour as well as shrinking. So we know it's you mentioned it was shrinking, but is it also fading in colour?
Yeah, g'day, Mark. No, it's not fading in colour. Over history, of course, it has changed its intensity in red, but it appears to be not changing in colour. But what we saw, particularly in 2019, were bits of red material that actually peeled off the Great Red Spot, and they were dragged down the south temperate belt as bits of garbage almost. But yeah, it's getting smaller, but it hasn't changed much in colour.
There we go. That answers that question. So now you can see Callisto is getting nice and bright. Really starting to see it now compared to a few minutes ago.
It's really good to see the diagram that Barry Adcock had, where it was a view from the looking down, showing the moons crossing that shadow line.
Yeah.
Whoop! Move motor to position now.
Yeah, changing focus.
We have another question. What gives the Great Red Spot its colour?
I think we're still uncertain about that, but whatever it is, it's coming up from deep down inside Jupiter, and it's thought to be just traces of sulfur and phosphorus compounds. They'd be compounds of sulfur, hydrogen, and carbon probably, and also phosphorus and hydrogen. And it's very difficult to simulate the conditions of Jupiter on the Earth, because if you go down deep enough, the temperatures are extraordinarily high and the pressures are enormous. So it's not just a matter of doing a bit of chemistry in a laboratory to see if we can generate the same colour. We've got to be able to generate the same pressure and temperatures as well. So it's getting back to the chemicals on Jupiter. I've always made the comment that if you look at the latest Juno pictures and pictures before that, it appears that there's quite isolated chemical clouds that don't mix. They've got sharp edges. It appears that whatever is next to it, that one set of chemicals doesn't like the other very much at all, and they don't mix together. But somehow or other, the whole thing has got to regenerate somehow. Jupiter, of course, has been there for billions of years, and we've been watching it for 400 years. And so somehow, whatever the chemicals are, they've got to be able to regenerate.
And Barry, for as long as we've had powerful telescopes powerful enough to see the Great Red Spot, it's always been there, hasn't it, since we've been viewing Jupiter?
Yep. Observations and pictures of it go back to the 1870s. The observations of it go back further than that. But I think it's fair to say that it's been there ever since. Of course, if we go back to the 17th century, the telescopes weren't good enough to see it anyway. I think there's no evidence that we've actually seen it generate ourselves. It's always been there as far as we know.
Now, we've got a couple of comments on the... so we're streaming across the Herald Sun Facebook page as well. And there's a couple... there's some funny comments on there. Far out, just read Jupiter is in isolation. I thought Delta had got there as well. Are we looking at Jupiter and some of its moons? Yes, we are. Dennis, we're looking at Jupiter and its moons, and they were going in and out of eclipse there. Hotel quarantine for Jupiter. Some good ones in there. What else have we got? Will it be in isolation for 14 days? No, it won't. Well, actually, it's in isolation now, isn't it? It's so far away from everybody. So we've got a couple more questions. Andrew wants to know, is the distortion of the moons due to the telescope or to the air?
I'd say both, in that I know that my telescope is a little bit out of collimation, but it's also, there's a lot of jet stream current at the moment. Yeah, we've had a lot of moisture in the air tonight, so it's really not ideal conditions.
And then we've got another one. What app are you using to live view Jupiter? So everyone uses different apps. Noel, what are you using? What program are you using with your telescope?
So this is SharpCat.
Okay, so hang on. Well, let's jump back across to your one. So this is Noel's screen. So Noel's using SharpCat.
Yeah.
To record Jupiter.
Yeah. So I can manipulate the exposure and quite a few other settings on the fly. It's quite quite good for this sort of thing. And
then we've got well, Andy. I think Andy's got Jupiter in there as well. We had Jupiter in there. You got a bit of, yours is a little bit redder. So Andy's got Jupiter in as well. What are you using? Using SharpCat as well, are you, Andy?
Sorry, me, Andrew. Yep.
Andy, he's on mute.
I'm back. Yeah, I'm shooting it through clouds, and I'm stretching
as much as you can. But you're using SharpCat as well.
Yep, using SharpCat.
Cool. We're going to jump over to Lee, who's got the Cleopatra Ringwood. Lee's using, what are you using, Lee?
SharpCat as well.
SharpCat as well. SharpCat Pro. There we go. So it's three of them using SharpCat, and Andrew is using Fire Capture.
I use Fire Capture.
Yep.
I'm just waiting for the buffer to finish. Sorry about that.
We've done some more recordings. Now we've got that beautiful colour and that beautiful image of Jupiter. I will say, Andrew, it's the best view of Jupiter live streamed we've probably had. I think this one. It's so clear. The bands are so visible.
And you can see down the...
I could make them more visible. I'll change the
Go on then. Go on then. There we go. Stuart,
on this program, you can see down the bottom the saturation of red, green, and blue. And so I use fire capture, but there's no difference between sharp cap or fire capture. It's just whatever the imager prefers to use. Really, there's no. They've all got their pros and cons. These programs.
I've actually, not that I've done too much in planetary, but any that I have, I've actually preferred to use fire capture simply because of a couple of extra tools it's got, including the auto align or auto guide, or
there we go.
Yeah, so that it basically keeps the image still on the screen.
Yep, it's good for focusing.
Yeah.
Now we've got another question. So Mikhail, he's asking lots. Could Jupiter be considered the vacuum cleaner of the solar system? How does it protect the inner solar system and us?
Well, it does have an effect, and often people say that it deflects meteorite material away from the Earth, but equally it might deflect it straight at us. So it certainly alters the cleaning of the solar system, and it causes major disruption to things like comets such as Shoemaker-Levy 9 that got too close to Jupiter. But yeah, it's fair to say that it has a drastic effect on the material close to it.
And that Shoemaker-Levy 9 was quite a spectacular event back in, was it 1994, Barry?
Yeah, it would have been about that, yep.
And it impacted the planet, and you could easily see the impacts on the planet because they were really dark. But back then... Yeah, go on, Barry.
I was just going to say you could see the impacts for quite some time, for weeks.
That's right, yeah. It really put some huge marks on Jupiter. But we didn't have digital cameras back then, so I didn't take any images. Did you get any images on film, Barry?
Yes, I did, yep. I used to use an Ilford FP4 film, which was a medium panchromatic film, and yeah, I did get images. Yep.
So we've got another question from the Herald Sun comments. Dennis wants to know if this is the closest point to the Earth that Jupiter will be, or is it not reached that point yet?
It's not reached the point yet. It comes closest to the Earth around about opposition, which I think is, the date escapes me, but it's around about the 10th of August. So it is quite close. It'll be in a few weeks' time, but that will be considered to be the closest approach for this apparition. Now, Jupiter's orbit, like the Earth, is slightly elliptical, so other apparitions like next year and the year after, they may be only a very marginally closer or further away. But yeah, closest approach is around about opposition time. And can you remember the date, Stuart?
I think it's August the 20th.
August the 20th, yeah.
So that's about 4 weeks from now.
Yep. So it's still growing in size right now. And then after that, it'll shrink. And then, is it every night you go out to look at this, Barry? It gets out earlier, about 4 minutes earlier a night, or 5 minutes?
Well, now that it's in retrograde motion, it rises about 4.5 minutes earlier every night, 4 1/3 minutes. But normally, under equilibrium conditions, it's about 4 minutes when it's rotating stationary with respect to the stars. Yeah, but at the moment, it's about 4 1/3 minutes earlier every night, and so it's rising tonight just before 8 p.m.
So every night it becomes more and more comfortable to view, so you don't have to start until 2 or 3 in the morning, which we have been doing.
Yeah.
Yes, I've seen some of those emails come through saying that the guys doing the imaging, the guys from Lunar and Planetary, have been sent an email at sort of 8 or 9 in the morning, and I was up at 5 a.m., 4 or 5 a.m. imaging Jupiter, and this is my photo. So the boys, they do it. The guys do a fair bit of work trying to get these images, and we have shared some on our Facebook page, and we will definitely share some more. There was a second part to that question, and that was when will this reoccur? So when will this sort of eclipse reoccur? It's quite common, isn't it? These sort of eclipses, aren't they?
They're very common. You see, the moons orbit Jupiter much faster than our moon goes around the Earth. Io goes around in roughly 1 3/4 days. The three of the moons synchronous orbits. Europa's 3.5 days, and Ganymede is 7 days, and Callisto is 16. So that's not quite a multiple of the others. But yeah, eclipses are common, very, very common. But when you see two at once, or two occultations at the same time, or one satellite passing another, that's a bit more uncommon. And what we're seeing tonight of a disappearance and reappearance within a couple of minutes of each other, that's probably wouldn't be repeated perhaps for a couple of years.
Now, I can see on Andrew's screen he's got a bit of a surprise for us. This was a Jupiter isolating stream, but he's obviously finished his recording on Jupiter and he's moved across to Saturn. Couldn't help himself. So we'll just go a little bit of
Saturn's always Saturn's the best one.
If you like it, then you better put a ring on it.
That looks good, Andrew. That looks really good.
Beautiful view of Saturn there. So
still looking through the cloud though. There's still clouds up there. It's very light.
Yes, it is. We will do a stream. We will do a stream. Probably not in the too distant future, focusing just on Saturn. So I think what we might do though, we've sort of we've done what we need to do with good old Jupiter. We've gotten that stream going with, we managed to see the coming in and going out of eclipse. The weather played along with us tonight for that. So I think we might start to close out the stream for now. We've managed to get that done. We do have another stream this Saturday night if the weather plays along. It is a bit of a national sort of stream. We've got the team from the Astronomical Society of South Australia, who are also in lockdown, jumping on a stream with us on Saturday night. We've got the guys over in Perth Observatory who do their live streaming. They're going to jump on for a little bit to give us a hand as well, even though they're not in lockdown. So it's a very nice thing of them to do. And we're hoping to bring you some live stacking from somewhere in New South Wales. We haven't quite locked that one in yet, but Saturday night is going to be a live stream lockdown extended edition, since most of Australia is still in lockdown at the moment. So we will see you guys again on Saturday night, but we do have one last question. Stuart or Barry or Andrew, whoever would like to answer it. Brenton, who is an ASV member. General planetary question. Do any of the guys use atmospheric dispersion correctors?
Well, that's right up Stuart's alley.
He's the cause of the clouds.
Yeah, I bought one 4 days ago, and I brought in all the cloud and the bad weather. So I might, once this finishes, I might go out and see whether I can use it. But yeah, look, a number of members of the lunar and planetary section use them, but I can't give you my experience because I haven't actually used mine yet. But I do intend to use it. By the way, that's a nice image of the Cassini division in the rings. You can see the division in the rings on Saturn. Yeah, look, I intend to start using it and learn how to use it, but at this moment in time, I don't have any experience.
Now, what does it do though? How does it help your imaging?
So the different layers of the atmosphere, when you're viewing a planet at any angle other than directly above, which is known as zenith, the planet's image is coming through the atmosphere, and there's different layers of atmosphere, and it behaves like a prism, and so it breaks the spectrum of colours from blue right through to red, the rainbow, into different colours, and it causes blurring in the image. so that the image isn't quite as sharp as it could be. And the atmospheric dispersion corrector has the opposite effect of the dispersion to cancel it out to give you a sharp image. But as per this moment in time, I haven't had a chance to play with mine, but I know plenty of people who use them. And the higher the planet is in the sky, the less effective they become, because you get a better image as the planet gets higher. So not only is opposition for Jupiter coming up, and it'll be the biggest, but if you wait to image it when it's nearly directly overhead, it'll also be the sharpest, because it won't get that dispersion.
There we go. Beautiful answer. So, Stuart, the clouds were also caused by me getting a Barlow, 5 times Barlow as well. So between the two of us, we have caused all of these clouds and all of this rain.
And I washed my car.
And you don't wash your car. This is why an astronomer should never wash his car. My car's not been washed in about 3 years. So I'll bring up back.
I bought a new G controller this week too. So, and it's
you're part of the problem as well. So
GPS and Barlow.
If everyone's bought astronomy equipment, and that is why it's cloudy, guys. So we apologise. We thank you all for coming along. We thank the Herald Sun for sharing this stream on their page for us as well. They'll hopefully be doing the same on Saturday night. And we thank all of you for joining us for this stream. And if you haven't got anything to do on the weekend, which most of us don't, come along. We're going to be hopefully looking at deep sky objects again, doing some live stacking of deep sky objects. Moon's going to be out, so we'll look at the moon. We'll try and look at the planets and probably some of the brighter nebula and star clusters, and maybe if we get a chance to, if we can, try and get some galaxies up as well. But until then, thank you everyone for coming along, and we will see you next time.
See ya.
Yeah, fine.
Bye-bye.